Hey, Sai, so... Oh, you were decorated?
Yeah. I'm busy, please.
Okay, but just one more question, okay? Yeah?
Stop.
Now that's better. Well, that was different. So, can I help you? I'm glad you asked. So, hello and welcome to another Stylegan YouTube tutorial. As you've seen in the intro, today we're going to talk about latent space morphing and how to render cool videos to morph between one image and another one. So, before I lose your interest, because quite frankly the result of the morphing in the intro didn't quite turn out as well as I hoped, let me put some more morphing video on the screen that shows some more of the potential of this technique if you have proper images and not just frames from a frankly not that well lit video recording. But yeah, this technique has a lot of potential, and if you have the right images it can produce great results. But before we go into all of this, let me first address and acknowledge that it's been a bit since my last video, and the reason for that is really cool actually. Some friends and I have founded a new math education startup called Concludio. It's based on a really cool concept that we came up quite a while ago during our studies. And what we offer is an online platform with math exercises to practice. And the real new approach is that you can just enter your equations step by step in our online editor. And we have let's call it an AI, run in the background that checks your solution for mathematical correctness and then tells you exactly and immediately where you make mistakes and what kind of mistakes you're making, and really tells you with a lot of feedback how you can improve your math skills. And I think it's really cool and can really help quite a lot of people. So if you want to support our startup, please give us a like on Facebook, subscribe to our YouTube channel, leave a couple likes on the videos, give us some love for the YouTube algorithm so that we have a little bit of a publicity boost and can get this program out to more people and help people improve at math. Right now the program is unfortunately only available in German, but we are going to localize it to English eventually, and if you give us a like on Facebook and subscribe to our YouTube, you will be one of the first to find out when it's available in English as well. And if you by any chance happen to be of the German-speaking part of my audience, just head over to Concludio Education, try out our program, send me some feedback maybe, and just tell me what you think about all of this. So, after that plug, let's talk a bit more about the technique we're going to use today. So, roughly the technique that we're using consists of 3 steps. The first step is getting an image and aligning it with the training data that we use to create this Stylegan model. For the faces, for example, we are going to use a computer vision software that was originally written for the Stylegan-1 encoder. That will just like detect your face, crop it out correctly to the 1024 by 1024 square that is used by the Flickr Faces HQ dataset and what all the Stylegan face generators are basically trained on. That will be the first step. The second step will be to project the image that we get into the latent space. That means we are running an approximation algorithm that was published with the update to Stylegan2, which was released a while back, called Stylegan2 Adder. They already had an approximation algorithm with the original Stylegan2, but the one that they published in Stylegan2 ADA is much easier to use, and so we're going to use that to create latent space representation and rendered images from the Stylegan model that will be quite close to the images we want to morph between. And then with that latent space interpolation that we get from this projection code, we're going to get two latent space representations of the two images we want to morph between and the generated images from the Stylegan model. And then we can use linear algebra to just calculate the interpolations between those two vectors. And then the beauty of a GAN model and the latent space will allow us to, for each of these interpolation vector, also render out an interpolation image that is somewhere between the two images that we want to morph between. And then little by little, frame by frame, we can get this nice transition where one image morphs into the other. And that's going to be the 3 steps that we use in this video. So get an image and align it to the training data set, project it into the Stylegan model, and finally we are going to render this morphing video. And then as an optional 4th step, you could also do some like post-production in Premiere or something else. Since the projected image will not quite match the original image that we have in mind, we can just do some opacity blending or some other transition in Premiere that will get us like the last 5 to 10% of the transition and have like this really nice smooth transition from one image to the other. So that's the plan for the video. You know all about the approach now, so let's get straight into the tutorial.
Hello, so you've just seen in the intro the morph effect I'm going for here in this video. And right now we'll travel back in time because now I'm just at the time where I finished the intro, except for the morphing part here. So I've recorded this close-up and this close-up, and then it goes back to the intro. And now let's actually get to the part where we morph from this face into this face. For the second one, I've actually recorded some more alternatives. So what we currently have is, this is the face we're going from. And for the target, we have these 3 choices right now. I'm not quite sure how well it picks up on the hair, so I'm gonna try, but like I have some options here, so I get with the one that looks the best in the morphing. So let's look at what we actually use for software. So I'm gonna use the Stylegan2 ADA encoding. It's a follow-up on Stylegan2 that was released a while ago, and they made it really easy to project images to the latent space, which is what we're going to use. So the plan again, we project an image to the latent space, then we project another image to the latent space, then we find an interpolation in the latent space between those two images and use that to render transitional images. So that's the plan, and for that we're going to use this projection script and also here from the old Stylegan-Encoder for the original Stylegan actually, that was done by Puza, or Puza, sorry if I mispronounce your name. He wrote some code that aligns facial images to fit exactly with the dataset parameters of the Flickr Faces HQ dataset. And that is very useful because that allows us to then project the images properly. And the code is align images code here. It basically just takes an image, does some computer vision to detect eyes and mouth, and then position it correctly and cut it to a 1024 by 1024 square, which we then can use to project into the latent space of an FFHQ, so Flickr Faces HQ model, which is the second step. And then And then the third step of rendering an interpolation. For that, I have written some script of my own that basically takes in 2 latent vectors here, which is what we get from the projection algorithm. And then we basically use linear algebra, just like simple weighted averages, to calculate the interpolation vectors that will then render interpolation images. And then it should hopefully output a video that morphs from one phase to another. So let's try that now. As you may have noticed from the Adobe Premiere and everything, I'm on Windows right now. So I'm not going to use the Docker setup that I use in the other videos, but instead I'm going to use a Anaconda setup that I use on Windows. If you have interest in seeing how I set up all of that, because it has some advantages in not having to switch between Linux and Windows, keep everything in one system kind of, if you have some other programs like Premiere that run on Windows, just let me know in the comment if you're interested in the Anaconda setup. So right now we have these images here, which are our candidates. So let's do the first step of cropping the images properly. So it's pretty simple. Basically, you just make a folder, raw images, or whatever you like actually. Copy your images in there, and then you invoke this script basically. Now, obviously I will have to use the correct folder structure. So we're here, the align image is here. So if we copy this, let's go up one folder here and here. And now it should load up the computer vision code to detect the face and crop it properly. Yeah, so simple mistake. It doesn't create the folder. We have to actually create an empty folder here with the name that we give here. So let's try this again. Okay, let's see what we got. Okay, we only got 3 images here. So this one, apparently too much hair, not a bit blurry maybe from the camera. Autofocus is hard to control sometimes. So it didn't actually detect the face. That's fine. That's why we had multiple options. But yeah, this is something we can work with. And now the next step is to project them into the latent space. For that, we're going to use this code here. Okay. So that is our code. As you can see, it gives a network pickle. If you haven't downloaded it already, it will just download it on demand as you execute it. Copy this code over. Go into the right folder, obviously. And now let's see. The out there I'm gonna call Morph1. And the target image is going to be up aligned images morph art 01 png. So it now downloads the required model, the FFHQ pickle file, which is just a pre-trained Flickr Faces HQ Stylegan model provided by NVIDIA. This should only happen the first time, and then it is cached and you don't need to download it again. So let's wait a moment. So the file has downloaded, the network has loaded, and now the actual projection is running. So let's have a look at what's going on in our folder here. We have the target right now. This is what it's going for. Oh, I really need to get some studio lighting to fix my camera setup and get some crisper images. So while we shamelessly plug Patreon for better images and better internet, let's see how the projection actually goes. it shows how fast it goes here. Basically, time that has elapsed, expected time to finish, how many iterations you can do per second, how close we get to this actual image in the Stylegan image set. That will vary a bit. Stylegan can't reproduce every conceivable image, obviously. It must be somewhat close to the training images, or else it just imagines something that doesn't really work. But it should work fairly well here. And there we go. So let's see how close we got. So this is our target image, and this is what Stylegan imagined we look like. With the hair, it's fairly close. The eyes, not that good. Eyebrows, well, fair enough. The beard itself and the lips look fairly decent. So now we can also see how this actual projection works, because the new Stylegan-Encoder code just gives us the projection steps as a video, which looks like this. So it starts with something more or less a random phase and then tries to adjust the parameter to get closer and closer. We can see the whole color scheme changes, and then it gets closer and closer to the image. My eyes are not that well. Doesn't really approximate my eyes all that well, but I think it's fairly close, and we have some Premiere tricks to get the last little bit of the transition going. So that should be good enough for now. This process is a bit random, and if you're not satisfied with the results, you can run it again. Actually, I'm just gonna do that to see if the second result is better. So let's go back here, clear the console so we see more what it's going on. So we run the projector script. We say the output directory is, let's call this Morph Art 1 now. Target is still Morph Art 1, the PNG, and the network is still the same file. Now it should recognize that this is actually already cached, as you can see here. It's a 370 MB file that you have to download on the first run of the projecting script. And I'm going to show you later that you can use different networks. I will bring back the Metropolitan dataset later on in the video to show you some more variety of what you can do with this morphing. But yeah, for now, let's see how our second attempt differs from the first one. Let's do it like this. Okay, so let's compare. Starts with the same, then goes for a color shift, and then kind of goes in the same direction. Eyebrows, eyes. Let's look at them side by side. So, which one of those do we take? Maybe get the original in here as well. So, as a bit of a hard choice, I think I like personally this one a little bit more, which was this one, I think. Yeah, just because I think the skin color here is a little bit nicer. The beard is coming up a little bit nicer. The eyes are a bit closer, maybe. Honestly, it doesn't really matter. Both are fairly close. This one looks a little bit more natural, I guess. So let's just go with this one. So this one is the latent file. That's the important part, which we need for rendering the transition. The next step is to project the other two images, which are these two, and see how that works. And then we will finally pick our best choice and render the transition. So let's do this whole thing again. So Don't use spaces, people. It messes up everything. Anyway, so I just attempted this a couple times in a weird way because I used spaces in the file names. Don't ever do that. It just messes up everything. But now I fixed the spacing here, as you can just see. So I'm gonna run this again for these two faces and see what I get. So little fun fact, why these are called Art and Pro. That's the names that I use in scripts and stuff for the personas. Art would be the artist persona and Pro would be the programmer persona. So little fun fact there. That's where my naming is coming from. So let's see how well my face is. Oh, okay. I mean, kind of. It didn't even pick up on the glasses. That's kind of disappointing. Yeah. I knew this was gonna be hard with the hair, but like, let's see how the optimization went. I mean, I guess that works, but I'm gonna, well, let's first try the other image to see if it works better there. So loading the whole network again, now trying to approximate this image here. Let's see how that goes. Well, it's not that impressive, but it's, I would say, we got the glasses, we got the hair working. This area is kind of not that crisp, but that is mostly probably due to my camera quality and not a problem with Stylegan. I will try some other images later, maybe just directly from Stylegan, to show you how powerful this technique is or can be if you have good image quality. But for now, let's see what we can do with it. So, we now have this face and these two latents, and we want to interpolate between them with a video. So let's look at that code I wrote. Render morph. Let's look at the arguments. Python render morph. The network would be FHAQ pickle, just lying around in the folder right now. Latent 1 would be here. It should be this one, but I think I had like a code problem where I reversed them. Let's try it anyway. One up, Morph Pro 4, delatents. Delatents 2 is then one up, Morph 1, delatents. And what was the last arguments? Truncation is not important. Name we can name this Morph. We go 1.4 and the out there video. Oh. And the out there we just call video. So it loads FHQ pickle, then it loads the two latents and starts rendering the video. And we currently render with a sine interpolation. So let's see how that worked out. Yeah, so the faces are not quite that accurately mine, but I think it's still really cool how the glasses appear and how the hair begins to shift around on this side. And I think this is a transition that we really can work with. So let's render also the 1.3. by the time I have uploaded that, I will probably have it fixed so that dlatents1 actually is the starting point and dlatents2 is the end point, not the other way around as it currently is. Okay, so video seems to be complete. Oh, if you select something here, it does weird things in Windows. Don't do it. So what do we have here? And here the hair actually falls down in front of the entire face. Looks decent. But I'm gonna use the one with the glasses now. So let's open Premiere again. Import this, move it around. And then we have something like this. Let's see how it works. Now, obviously, this needs some more alignment. But I will now skip over that part. I mean, if you're interested to see more behind the scenes work, I will maybe upload this to my Patreon. Shilling wherever I can. You will see the final result, but that's how I got to this morphing video. Okay, so let's see how we can actually use this with some proper decent images. And for that we go back to the Stylegan-Encoder, and maybe we use just like some example images here from FFHQ. Let's just look at these. Yeah, why not? So we save this image here. Sure. And this image here. And now we run the projector again. This time our target is just 0001 PNG. And the out there, let's call it 0001 as well. And let's see how that works. And here we go. Let's compare them actually side by side. Now you will notice, since this target image here was actually originally created by Stylegan. So here it's the curated example images. The projection actually approximates the image extremely well, since it's exactly in the data capabilities of the model. So if we switch around here, you see some differences, but it's, I mean, much closer than what we got earlier with my images. Let's do the same for 0007 here and here. And here we go. Let's see. That's pretty close, pretty close. So let's see if we can morph from one of these faces to the other. We go back to our render. Let's do 1.7 sin. And then this would be 0001. This one is 0007. Rest stays the same. While this is rendering, let's actually look at the projections. So here we can see the approximation has a much easier job to not adjust for like weird color grading or anything, but it just goes straight to a rather natural looking face that's pretty similar. The eyes look a little bit better and more alive. It's just this kind of face is much more in the format that Stylegan2 can handle and not, or that this model can handle and not like my face, the images of my face at least. Here we go again. And as we can see, it's pretty much, it goes from here very fast to a pretty similar face, and then just tries to get like the alignment, beard, the little details quite right. And converges pretty fast actually. It just kind of vibrates here, it doesn't do much anymore. Okay, and meanwhile, this has rendered. So let's see how it looks if we actually do it between two well projected faces. And here you can see it's a very smooth transition. The face turns a little bit, the face shape grows a bit, the hair grows quite smoothly. You can even see like individual strains in this part elongate and kind of, wow, that's actually pretty cool. It's kind of better than I expected. So why did I call this 1.7 sin? Because this is the sine interpolation. Let's actually try the other ones. So I haven't yet put a command line flag for this. I probably will do that when I upload the video and adjust the code as well. But for now, I'll just go into the code and edit it. So I will just go into my code here and edit this file with idle, simple Python. So all I need to do is, so this is the sine interpolation. I'll just comment that out and do like a quadratic interpolation instead. Nope. Let's call it square, so we don't overwrite the old video. And then I'll do the same one more time for the linear, and then I will put them all together in Premiere side by side so you can have a comparison. And here it is from the editing. So we have the square interpolation on the left, the sine in the middle, and the linear on the right. Let's do this again on half speed. Very smooth. And my personal favorite is the sine interpolation, as it has a slow and smooth start, then kind of a rapid transition in the middle, and then a smooth end again, coming almost to a static. But there's really no right and wrong here, and whatever works for your project or fits your taste, that's a good function. I know, for example, that some people in the shader community have like much more complicated functions, but just try for yourself. And just like that, it's time for Metropolitan again. So here we have three objects, a ring, a coin, and another ring that I'm projecting into the latent space. no alignment needed, as these are like images from the actual training set that I used. And this is the final result. Here I used a bit more post-production here in getting from the target image to the projected image. But this morphing process in between is completely done in latent space from here to here, post-production, and post-production back into latent space morph to the coin, post-production to the coin, and post-production into latent space morph into the ring, and this is how it goes. So I really like this result. There's certainly some improvements to be made on like projecting and using a data set or a model that is trained for a bit longer. This was only trained for like, I think 8,000K images or something. Or at this stage, probably even like 6K. So there's more room to be made and more improvements to be made on the quality to reach that kind of level that we saw in the FFHQ with the example phases. But this approach in general has a lot of potential, and I would be really happy to see anyone sharing their own results. So maybe just leave a comment below if you ever apply this and show off your work.
So, thanks for watching all the way through this video. At some point I'll get these tutorials maybe a little bit in a shorter edit than like the 30-40 minutes that I'm currently having. But I think it's quite valuable actually to also show some of the little mistakes that you do with manipulating code, or yeah, just the little things that can go wrong and how to recover from that. That is a big part of doing any kind of creative coding, in my opinion. That's a big part of doing any kind of creative coding or coding in general. And I think it helps if I actually show the little mistakes that I run into and how I can solve them. So yeah, maybe these videos will stay around the 30-minute plus mark, but I guess that's fine. So, as always, if you enjoyed this video, I have a Patreon, I have an Instagram, like and subscribe. And once again, I'm now part of a math education startup. If you want to support that endeavor of mine, please just head over to our Facebook, give us a like there, head over to our YouTube channel, leave a subscription and a couple likes for the YouTube algorithm so that we can get some publicity for a cool new project and help people learn math better. And if you speak German, maybe just try out the program yourself at concludio.education and tell me what you think about it. So yeah, thanks again for the audience that I'm given here. It's been quite a ride on YouTube. 200 subscribers already feels like a lot, and it's really cool to see the channel grow, even if I haven't been all that active. And it's just quite cool that the content is appreciated in the way that it currently is. So thanks a lot. And if you manage to get any cool results with this technique, leave a comment, write me an email, tell me about it, and maybe I can showcase some community work later on this channel. I would really enjoy that. Yeah, I think that's it. So just thanks again and have a good day.